Hey guys, today we are going to talk about dynamic Lambda authorizers. So why custom authorizers? Well, they allow you to customize your authorization scheme based on your requirements. You can implement fine-grained authorization to resources, and you can use databases to make the authorization more dynamic. I'm going to talk about how you can actually do this in AWS later on, but for now we're going to use that. We are going to look at the use case we are going to follow. So here we have some nodes, and then he wants to be able to share these nodes with Annie. And later on, he decides to deny access to these nodes to Annie. So our database is going to look like this. We're going to have a primary key. It's going to be username. Our sort key is going to be title. And then we're going to have attributes, content, and permissions. So in our case, Huey is the primary key. The sort key will be the name of his nodes. In this case, it's called my nodes. And the content will just have the content of the nodes. And the permissions, we will have a very straightforward array that has username of the username that's trying to access the resource and the actions they can perform on the resource. So CRUD stands for create, read, update, and delete. So if it's just C or U, then Annie cannot delete the nodes. But if it has R, then you can read Annie can read the nodes. So this is very straightforward, just to show how it works. So it's not we're not diving deep into DynamoDB or anything. So this is how it works. So just you send a request to API gateway with a token, and then API gateway invokes Lambda, and then with the token and context, and then Lambda can use all of that to either allow or deny the request, and it does that by creating a policy, and then it sends the policy back to API gateway. If it's denied, then it's not, you cannot access the resource. And if it's allowed, you can access the resource. You can also cache your policies. And we are going to use Amazon DynamoDB, just as I said, to make this more dynamic. All right, so let's do a quick overview of what the solution will look like. So as always, we already did our CDK in it, and we added some code. So in our stack file, we have our API here. So this is our API. And we have our method set, and we have our logging enabled. So we can easily access our logs here in the toolkit, or you can also access it from the console, to be honest. But this is always helpful when testing and debugging. So I always turn mine on. Right, so that's the API. And here we have the auth struct. Resources. And this is just like the other ones where we handle signing up and signing in. So you have the credentials row here, and then you have the resource and the method here, and simple mapping. So we're not going to go for that too long. So that's auth, and here we have our custom authorizer. And this is our function. As the authorizer itself is here. Then you can set a cache here, and this is where you can set the identity sources. They explain it here, but that means that we're going to use the token that's given in the authorization header. So, yep. So this is a request authorizer. And then you have to use your function in there. So the function is here. This is just a standard Lambda function, um, how you do it in CDK. And then here we have our database struct with all of the resources. I'm going into that one in a bit. And then we're adding the DynamoDB table name as an environment to the function. And we're also adding the policy so it can access DynamoDB. You can literally really change this to get item, but I just put it to start. Okay, so before we go into the database struct, I think it's more important for us to look at our Lambda code. So our Lambda code, we have some modules here. You can put in a Lambda layer, but this is the only function I'm using it for, so I just put it in here. Okay, so the Lambda code, I'm getting these from my environment. This is my DynamoDB client. Okay, and then we're using the JWT verifier to verify the token. And this is just for testing purposes. I have a console log here. Now we get the claims from the verifier when we verify the token. And then we store all of the data that we need. This is done like this because of what the database looks like. So if you want to get a node, it's going to be in shared nodes. So if you want to get one of the shared nodes, it's going to be in shared nodes, resource, username, title. So this is there's something in, I think it's get is in front of this in the path. So this is first index, second index, third index. And the zeroth index is the method, I guess. So that's why we have our username at 2 and the title at 3. Console log it just to make sure we have everything in testing. Of course, when you're not testing, you don't have to do that much console logging. And then we have a get permissions function that gets the permission from the database. And then we find the permission based on the username. And then we console log it for testing. And then we did it easily, right? We just said CRUD. And then if it has the R, that means that you're allowed to invoke this function in order to get the item. So then we generate the policy. We send all of this. This here is for the context, but this here is enough. So you generate the policy like this, and if the R is not included, then you generate a deny policy. Right? And yep, that's it. That's it. This is the generate policy function. It's just standard IAM policies. Let's see. Yep, that's it. This is how you get the permission from the database. And let's take a quick look at our database. So this is what it looks like when you get a shared node. This is this is how you can add a node. And then just because you always have to do some extra work with your JSON because it's not really application or JSON. So you have to like do some logic to get it as a VTL string. So the way I did it is I have my list, then I have my array here. That way I don't have to worry about quotation marks around my array. And then I have my backticks here, and this is where I put some VTL. So this is the for each loop from VTL, and you can find this in the docs for VTL. I'll have it in the description. And then it'll loop through all of the permissions you're sending. So this is what the body looks like. And then it will actually format it in a way that DynamoDB understands. And you need this line because this returns a Boolean. So if it has a next value with the comma, if you don't have it, if you're at the last value, you skip this and then you just go to end. So the problem with this is that you'll have quotation marks around this, and then ultimately when it changes it, when VTL processes this, then you have the correct transformation here, but it's in quotation marks, and that messes up everything. So then we're just using a VTL serializer, just like the other one, and then we just say which keys we want to target, and then we add replace flags, and then using the replace flags, we can remove the quotation marks we don't want. I also remove this because the stringify has a lot of these as a result, because I'm using backticks in my code. I'm using backticks in my code. All right, so that's probably that's it. Yeah. So for the test, we did a VTL test with this, and here you can change the access. I commented this out because the user is already signed up. So you log in the user, you get your token, and then you get node. This is the username of the owner of the node. Then this is the title of the node, and then this is the token. And then if you try to get node, the authorizer is going to be invoked, and it's going to see if it's going to check if you have the permissions to do that. And if you do, you can read it. If you can't, you won't. So let's demo that really quick. So as you can see, I ran the access nodes and I was able to retrieve the data. So what I'm going to do now is I'm going to change the permissions to this. Okay, so I already changed to that. And then I'm going to say just adding. It's going to match this test. And then it's going to change the code, the record in DynamoDB. And this allows users to dynamically change who has access to their resources, right? So that's cool. And then now Annie is trying to access the node, and then it fails. And then you get the message, user is not authorized to access this resource. So so that's about it. Yeah, and I think it's really powerful to use custom authorizers. So I think it's a fine way to have your own ways of your own logic of authorizing a user. So I hope you learned a lot, and I'll see you in the next one. Oh yeah, CDK is strong.